Again, we're working with implicit differentiation, and this is a word problem that's going to involve that. Okay, so it says here, suppose that x and y represent the amounts of two basic inputs for a production process, and the relationship here is given as 10 times x to the 1/2 power times y to the 1/2 power is equal to 600. Okay? They want us to find dy dx, or the derivative of y with respect to x, when x is equal to 50 and y is equal to 72. So, really what we're looking for is a numeric integration, numeric differentiation so we're looking for dy dx when x is equal to 50 and y is equal to 72. Okay? That's our goal here. Well, first off, we're going to take and rewrite our equation. So we've got 10 x to the 1/2, y to the 1/2 is equal to, again, this whole thing is 600. Okay? And again, we're looking for derivative of y with respect to x. So what we're going to want to do is differentiate the entire equation with respect to x so that dy dx pops its head out. Okay? So we're going to want to take this entire thing and find the derivative with respect to x. Okay? Just separate ourselves here. Okay? So first thing I'm going to do is I'm going to move this 10 to the other side because the 10 isn't really going to affect anything. It's a constant. So as I divide both sides by 10, these zeros cancel, and we really have d of dx, x to the 1/2, y to the 1/2 is equal to 60. Now we can go. Okay? So what we have are two powered functions here, and there's a product that's going to be happening in between them. So we're going to need to use product rule and general power rule here. Well, ddx of x squared, or x to the 1/2 times y to the 1/2 is going to be the derivative of the first times the second plus the derivative of the second times the first. Let's do that right now. Okay? Derivative of the first is going to be 1 over 2 times x to the 1/2 times y to the 1/2 plus the derivative of y is 1/2 y to the 1/2 on the bottom here, because as we subtract 1, it's y to the negative 1/2, so we stick that below. And the derivative of y with respect to x. And we're taking this whole thing times x to the 1/2 power. Okay. So what I see here is all of this set equal to the derivative with respect to x of 60, which is simply 0. Okay. Now it's our job to turn everything here into something that's equal to only dy over dx. Okay. So we're going to have to isolate and move some things around just using algebra. So what I have is 1/2, that's x to the negative 1/2, y to the positive 1/2. That looks like 1 over 2 and y over x to the 1/2 power. Okay, 1/2 is that, plus, now it's 1/2 of x over y to the 1/2 power. Because as this multiplies through, and it's all of that, times derivative of y with respect to x. Again, this whole thing is equal to 0. Now I'm going to take it, I'm going to move this over to my other side. So I'm subtracting 1/2 of y divided by x to the 1/2. That gives me is 1/2 of x over y to the 1/2 power times dy over dx, and it's equal to 1/2 times y over x to the 1/2 power. Okay. What we're going to divide by is this quantity right here. X over y to the 1/2 power. Okay. So here, this is going to cancel out, and I'm actually going to take this value up to my other side here, and just rewrite right now dy over dx is equal to negative 1/2 divided by 1/2. Well, that's going to be the opposite of y divided by x to the 1/2 power over x divided by y to the 1/2 power. And it looks as though we're not able to do anything here, but if you remember the negative exponent rule of how x to the negative 1 is actually 1 over x, well, what we could apply is a negative exponent rule right here. Okay, and we're going to apply this negative exponent rule, kind of impose that on our denominator here. So this is going to become dy over dx is actually equal to opposite of y divided by x to the 1/2 power, again all divided by y over x, and really I've taken the inverse of that, so this now becomes to the negative 1/2 power. Okay, so now we have y divided by x, we have a common base, and so this whole thing is going to be equal to the opposite of y over x to the 1/2 minus 1/2, or first power, is equal to dy over dx. So now we can evaluate dy dx, where x is equal to 50 and y is equal to positive 72. It's equal to a negative 72 over 50, which is equal to, we can divide by 2 there, a negative 36 over 25. So, dy dx, when x is 50 and y is equal to 72, is this 36, negative 36 divided by 25.